All right, welcome to day 3. Homework is packet page 27 to 29. And take a second and pause the video and see if you can do the warm-up in your Wednesday box. So we get our skewed data when we have outliers. So skewed to the right would look something like this because there's a tail to the right. So we would have an outlier on the high side. So we'd have a large outlier that is causing the data to be right skewed in the direction of the outlier. All right, so on the homework, we had our box plot. You could put in a list and spreadsheet. You could do your stat calculations and get your 5-number summary, your max, your min, your median, your Q1, your Q3. Remember, the number line needs to be spaced out by a consistent scale. Tally up your frequency for each of them, and then draw your histograms, your intervals. We had a squiggly because we didn't start at 0, 50 to 59, 60 to 69, and so on. You should not have any gaps in between your bars. And then make sure you have frequency and intervals labeled on your axis. All right, so we're going to go to packet page 15. So we're going to start out by looking at shape, center, and spread for data. So on the bottom of 15, so there's 2 ways to measure the center of the data, mean or the median. So mean, you add them all up, divide by how many are there. And in the median, you would put them in order and cross off high and low, working your way towards the middle. If there's only 1 in the middle, that's your median. If there's 2 in the middle, you would take the average of those 2, and that's your median. Now we have a way we can do that on the calculator. So what we're going to do is we're going to practice finding these on the calculator. So you have this right on the top of page 16 in your packet. Now in your packet we have 2 columns. We're just doing this to practice inputting the data. So we're not going to do both of them. So we're just going to do that first column when we put it in the calculator just for the practice. So we're going to, on your calculator, first off, it's helpful if you have other stuff open, go home and go new number 1. And you don't, if it says, do you want to save it, select no. So we're going to go to a lists and spreadsheet. Now we're going to put ours all in one column, so we have to give it some title. I'm just going to call it A. And please be doing this in your calculator as we go along. Okay, the best way to learn is to practice by doing. So again, we're only going to do that first column on the top of page 16. So we'll put in 58.2, hit enter, 59.5, 60.7, 60.9, 61.9. Now, one of the most common errors I see is when a value is listed twice. So notice there's another 61.9. Then we got 2 62.2s. 62.4, 62.9, 63.9, 63.1, and 63.9. Now I think it's always helpful to just take a second and double check that it matches your values because it's easy to make a mistake. So I'm just going to go through, and you should do that on your own as well, and make sure that they match. So like Okay, so they look like they match. So then you go to a blank box, and you're going to go Menu, number 4, Statistics, Stat Calculations, and we're going to do a one variable stats. We will always do one list, and then we have to tell it what the name of our list is. So we're going to have A. If we had had a frequency list, like that told us how many times each of those happened, we would put whatever the title of that column was. But we did not, so you just leave that as 1 if you only have one column of things. And then go down and hit OK. So, if you look at page 17 in your packet, it points to you which one is the mean and which one is the median. So the mean is at 61.82 or so. The SX and OX. SX is your sample standard deviation. The OX is your population standard deviation. Then you got your min, your Q1, your median, your Q3, and your max. So our median is 62.2, while our mean was 61.8. So maybe there's some slight outliers on the low end, which is why the mean is a bit below the median. All right, so that's how you would put the data in and do your one variable stats. So if we go ahead a little bit, so this is the bottom of page 17. So the mean is sensitive to extreme values. So if you have an outlier in the high end, it's going to pull the mean higher than the median. If you have an outlier in the low end, it'll pull the mean lower than the median. Outliers result in skewed distributions, and your skewed, when you're looking at it, is where the tail is. So if you had something like that, it would be a right skew. If you had something like that, it would be a left skew. The mean is not a resistant measure of center because it can be influenced by outliers. The median, on the other hand, is resistant to outliers. So the median, again, if there's one middle, it's just that thing. So 3.4 on the left. If there's 2 in the middle, we would add them and divide by 2. So we get 3.35 for our median in that case. On the bottom of page 18, if your data is symmetric, the mean and the median should be roughly the same. Now, in the calculator ones that we put in, they weren't that far off, really. So our data is probably pretty symmetric, maybe with some slight smaller values that pulled the mean to the left. Now, we will see this idea again some point in the unit. If your outliers are on the low end, notice the mean gets pulled left of the median. If the outliers are on the high end, notice the mean gets pulled to the right of the median. So the outliers get pulled in the the outliers cause the median to be pulled in their direction. And the outliers are shown in the picture by where the tail is. So here's just another example of that. The mean, so this mean has been calculated 2 times. The 3.4 is the mean if you did not include the outlier. The 4.2 is the mean if you did include the outlier. So notice that one outlier pulled that mean up by 0.8. On the bottom of 19, you have an example of a symmetric distribution where the mean and the median are the same. But on the right, this is a right skewed distribution. And notice the mean got pulled to the right. The mean is 3.4, the x with the bar on the top, while the median is 2.5. So we're going to the top of page 20 now. An outlier is any point that is distant from the other ones. It could be just due to variability. It could be some issue with the way that the data is collected. So it's important to identify the outliers and think about why they could have occurred. Okay, the big idea though is if the data is skewed or symmetric with outliers, then we need to choose the median. So anytime there are outliers, we want to use the median. If there is not outliers, so if it's symmetric, if it's nice, then we would use the mean as the measure of center. So the mean is not a good measure of center when there's outliers. An example would be, say you took 5 people's yearly income, but one of those people was LeBron James. Would you want to use the mean or the median to get a good sense that would represent the group's average income? Well, if you did the mean, LeBron James makes so much that the mean would probably be millions of dollars. But that likely would not be representative of the group as a whole. So it would be better to use the median because LeBron James's income would be an outlier. So there's 2 different measures of spread, so how spread out the data is. The first is what's called the interquartile range. Now your quartiles, Q1, and these are things that come up when we do the one variable stats. Q1 is the median of the lower half, and Q3 is the median of the upper half. And we saw those in our box plot on the other day. If we go to the bottom of page 22, the interquartile range, sometimes abbreviated as IQR, can be found by just doing your Q3 value minus your Q1 value. That tells you the range of the middle 50% of data, and that can tell us how spread out the data is. If that number is big, then the data is pretty spread out. If that number is small, the data is not really spread out. We like to use the interquartile range when at the same time we use the median. So if there's outliers, we would usually use the interquartile range to tell how spread out the data is. The other way to measure spread, this is on the top of page 23, is using standard deviation. It's the most common measure of spread in statistics. And the standard deviation tells us how far the observations are from the mean. So that underlined thing below there, standard deviation is just the average distance from the mean. So if you were to calculate it, you would take each data point, you would see how far are they away from the mean value, then you would just average those distances. So for an example, say we had 1, 3, 7, 1, 3, 5, and 7, let's say. So if we added those up and divided by 4 to find the mean, we would get 4. So the mean is 4. We would want to see how far each of those away from 4. Well, 1 is 3 away from 4. 3 is 1 away from 4. 5 is 1 away from 4. And 7 is 3 away from 4. If we add those up, we get 8. Divide that by 4, the total number of things, and we get 2. So our standard deviation of these numbers would be 2. That means on average, they are each 2 away from the mean. The bigger a standard deviation is, the more spread out your data is. The smaller a standard deviation is, the more compact your data would be. So going to the top of page 24. So the standard deviation should only be used if you're also using the mean as the center. So that would mean if there's no outliers. If there's no spread at all, then your standard deviation would be 0. And as standard deviation becomes larger, that means your data is more spread out. So a main summary from these slides: use the mean and the standard deviation when it's symmetric without outliers. Use the median and the interquartile range if it is skewed or has outliers. So just some symbol reminders. So mean is the x with the bar. The standard deviation on the calculator, if it's the sample standard deviation, you'll see it as SX, and the population looks like an O and then an X. And we're going to finish off in this video. We're going to jump ahead to page 26 to this example. So we want to find the mean and standard deviations of the salary range. Well, if they want you to find standard deviation, we want to know if we should find the population standard deviation or the sample standard deviation. Well, let's see what they're representing. A small company has salaries for their 50 employees as given in the table below. If it's the salaries for their employees, that's implying that it is all of their employees. So therefore, we should use the population standard deviation, whose symbol is OX. So we are going to go back to our calculators, and we're going to add a new list and spreadsheet page, and we'll do a one variable stats for this table. So I think it's always beneficial to go home, do one for a new document. No, we don't want to save it. Do your list and spreadsheet. So I like to just always title mine like A and B or something like that. And then you'll want to be looking at your packets so you can fill in the table as you go. After you've typed them in, it's always beneficial to double check, make sure you typed it in correctly, because one slight error will throw off all your numbers. All right, so go to a blank box, and we're going to go Menu, Statistics, Stat Calculations, one variable stats. We always do one list. Okay, the second column there is a frequency. It's not new salaries, so that's why it's just one list. We'll put in A for the first one, but we have a frequency column now, so you're not going to leave that as 1 like we did before. So we got to put in whatever we titled it. I called it B. If you called it something different, you would have to do that. And go ahead and hit OK. And we get each of our values. Well, the first thing we wanted in part A was the mean and the standard deviation. So our mean is the X with the bar, that 42060. And we had determined we wanted the population standard deviation because it was all employees. So we want that 16,000 number there. So our mean was the 42060. And our population standard deviation was the 16567.9328825. Part B, what's the median for the data set, and why is the median considerably lower than the mean is? So our median, we got to keep going down, is 32,000. So we need to think about what we talked earlier. Why would a mean and a median be so much different? Well, the median is resistant to outliers. The mean gets pulled in the direction of outliers. So because the mean is much higher, there must be high outliers. So a high outlier made, instead of made, let's say pulled the mean higher. If you look at the chart, it's that 120,000. The other ones are more compact, but 120,000, that's 45,000 away from the next closest. And the range from the 25,000 to 75,000 is only 50,000, so that's a big gap. So that's why that one's an outlier. Now, part C, we're going to do something that's a technique we'll use quite a bit. So does more or less than 50% of the data fall within one standard deviation of the mean? So what you do is you start with the mean. So we're going to start with that 42,060. And we are going to subtract one standard deviation from that. And this will give us a value that represents one standard deviation below the mean. And for that, we should get 25,492.0671175. So that's where we are below the mean. Well, now we have to start at the mean and go one standard deviation above. So we will add our standard deviation on. So that would be 58,627.9328825. So if we jump one of our average distances, that's what the standard deviation is, the average distance from the mean. If we jump one of those in each direction, let's see where that puts us into the table. Well, 25,492, that would be in between those two values. And 58,627, that would be in between those two values. So the ones in between are right there. If we add those up, there's 42 of the 50 total. So, does more or less than 50%? Well, half of 50 would have been 25. 42 divided by 50 is actually 0.84, so we would say more than 50%. And that idea of looking at a window that is one standard deviation away in each direction from the mean, or two standard deviations we'll see as well later, is something that comes up in statistics quite a bit. All right, so you have the Unit 2 Day 3 homework left to do, and upload that right to Schoology.